quick. I will put the time marks for each of these in case you just want to see one, but I'm going to put it all into one video just to be easy. This first one we really went through a lot in class, so I'm not going to spend a ton of time on it. But just remember that this per day is kind of misleading right here. It's a base fee of $52 for a day, and then on top of that, you're adding 23 cents per mile. So if we're defining our variables, starting with that, I like to use X and Y. You can use whatever. Think about what things we don't know. We do not know how many miles they're driving, and we do not know how much it costs. We're trying to find the total cost per day. All right, so I'm going to set X as my number of miles. Okay, I know that X is going to be my number of miles because it's going to go with our rate, 23 cents per mile. If you think about slope-intercept form, rate and X kind of go together. And then Y is going to be our total cost. Okay, you can also kind of think about it like independent, dependent variables. Total cost depends on miles. Y is dependent on X. Okay, so as far as our two equations go, for our standard rental plan, we know we're writing in slope-intercept. Our rate is 23 cents per mile, so 0.23x, plus the $52 for the day, okay? Our deluxe plan is a little bit different, okay? It's still y equals, but our deluxe plan is unlimited mileage, which means that our rate per mile is actually 0 cents per mile. We know that 0x is actually the same thing as just 0, so 0x plus 80 would be the same thing as just writing 80, okay? Because no matter what our miles is, it's going to cost $80. All right, now it's time to solve these using any method. You can do whatever you want to do. When I have two things equal to y, that kind of tells me I probably want to use substitution. I already know that y is equal to 80, so that's pretty easy. So I'm just going to rewrite this as 80 is equal to 0.23x plus 52. And then we can just go through and solve this like we would solve any equation. We're subtracting 52 off of both sides to get 28. Is equal to 0.23x. Then you're going to want to divide by 0.23. You get this crazy, crazy long decimal, which is why I put this down here, round any long decimals to the nearest hundredth, and it ends up rounding to about 121.74. Okay, so that's our x value. That's part of our answer. And this one's actually really nice. Normally, we would have to take this number and sub it back in for x to solve for y, but we're actually already told that y is equal to 80, okay? We don't have to do anything there. It just says y equals 80, so we can take their word for it, and that's our solution. As far as what this means, remember that x is our number of miles, and y is our cost. So this just means that they will cost $80. Both plans will cost $80 after 121 miles. So at about 121.74 miles, both plans cost $80. All right, pause this if you need to take a look at this. We're moving on. Okay, slide 2. This is where we are graphing in order to solve. Our first one is just in slope-intercept form, so we're going to need to graph our slope and our y-intercept for each equation. So my first equation we'll do, whoopsies, my first equation we will do in pink. Let's try to get that line away. What have I done? Okay, we'll graph this first one in pink. So we've got a y-intercept of 5 and a slope of 1/2. Tells us to go up 1 over, whoopsies, up 1 over 2 between our points, so it ends up looking something like this. I would go ahead and draw in a line to connect it all if I were you guys. All right, and then for our other one, this is starting at -2 and has a slope of -3, which means we go down 3 over 1. So we start at -2, now we go down 3 over 1. Okay, and if you need to reverse this to find the exact point, we go over 1, up 3 instead, and hopefully you guys are able to see that those points or those lines cross at this point right there, which would be -2, 4. Okay, our second one is a little bit more complicated. These are in standard form. All right, so you can do this one of two ways. You can find your intercepts and graph them by making like little tables if you want to with x's and y's, or you can change these into slope-intercept form. It's up to you. This first one's pretty easy. When we have an x value of 0, y has to be 2 because 0 plus 2 is 2. Same thing the other way around. When y is 0, x has to be 2 because 2 plus 0 is 2. So that's our first line. We've got a point at 0, 2, and at 2, 0. Now, this one's kind of hard to graph exactly, so just be really careful. I can see my slope is going down 1 over 1, so I'm just going to extend this a little bit in both directions just to make sure my line is as exact as possible, because it's really, really hard to do this, especially on a computer. It's hard to make it exact. So you want as many exact points as possible. All right, our next equation is a little bit more complicated. When x is 0, remember that makes that cancel, so we end up being left with 3y equals 12. So y would have to be 4 because 3 times 4 is 12. All right, when we do the reverse, when y is 0, these cancel, so you're left with 2x equals 12. You divide by 2, you find that x is equal to 6. So we've got a point at 0, 4, and at 6, 0. Once again, I'm going to try to make my line as specific as possible. I can see I've got a general slope here. It's going like down 2 over 3. That's that point in between. So I'm going to try to extend this to find the exact point of intersection, which we can see is right there. Because if you just drew in the line, you might have a hard time finding exactly where the point is. It's really hard to do these exactly on a computer. So our solution is that point right there, which is -6, 8. Okay, pause this if you need to see what's going on here. Moving along. Okay, slide 4 and 5 are both dealing with substitution. Remember, substitution is when we are taking a variable and replacing it with a number or an expression, something it's equal to, so that we can get an equation with just one type of variable in it. So in this case, this is a prime example of substitution. Y has already been solved for. I know that y is equal to 3x plus 6, which means wherever I have a y, I can replace it with 3x plus 6. So when I substitute this equation, we're going to get 3x minus, but stop, instead of y, I'm going to write 3x plus 6 equals 11. So I took that and I replaced my y with 3x plus 6. Okay. Then we're just going to distribute. Make sure you distribute that negative out. So we get 3x minus 6 equals 11. Start simplifying. So 3x minus 3x, those end up giving you 0. They cancel. And we're left with -6 equals 11. And you might be thinking to yourself at this point, hey, I messed up somewhere. -6 doesn't equal 11. Remember, if your variables cancel and you're left with numbers that don't equal each other, you didn't mess up, more than likely. It just means that this equation is no solution. These are parallel lines. They'll have the same slope. I can tell that if I were to move that to the other side and then divide by -1, I would get a slope of 3. They have the same slope, but they have different y-intercepts. So they are parallel. There is no solution. Pause here if you need to take a closer look at that. Okay, our next substitution. So notice here, y had already been solved for. On our next one, y has not been solved for, but what makes me think I should use substitution here is because y is already kind of by itself. There's only one step we need to do to rewrite this equation to get y by itself, and that is to get rid of this -5x. So to solve for y, so we can substitute, I'm going to add a 5x to both sides, and that ends up giving me this equation, y equals 5x minus 3. Now I know what y is equal to, so I can go to my other equation, and I can replace y with what I just found that it is equal to. So when I do that, when I take this equation, I'm going to end up getting 3x minus 8. Instead of y, I'm writing 5x minus 3 equals 24. And then we're just solving. So we're going to distribute. We get -40x plus 24 equals 24. 24 on both sides. We can subtract 24. That just ends up canceling. So we're left with 0 is equal to -37x. Okay, remember that it's not x equals -37. We have to do that step of dividing by -37. to find that x is 0. Because 0 divided by anything, well, besides 0, is just 0. Okay, so that's part of our answer. Now we got to solve for y, excuse me. You can use one of these equations if you want to, but remember this equation is already solved for y. Don't make your life more difficult than it needs to be. So I'm going to just use that equation again. Instead of x, I'm going to write a 0. So 5 times 0 gives me 0. So y would be -3. All right, pause here if you take a closer look. All right, our last two slides are dealing with linear combination, otherwise known as elimination. Remember, the purpose of elimination is to eliminate or get rid of a variable by adding together our equations or subtracting them. So if we take a look at this equation, remember we want to eliminate something. So that means that we have to start off with variables that are the same but different signs. We don't have that going on. Our x's are lined up. Oopsies. Our x's are lined up, our y's are lined up, and our equal signs are lined up. But if we were to add this up together, nothing would cancel, nothing would eliminate. So when that's the case, we're going to have to multiply one or both of our equations by something that will make them cancel. In this case, I see 4x and 2x are very similar to being the same. So I'm going to multiply this entire second equation by a -2, because that will make 2x become -4x. And when I add 4x and -4x, they will eliminate each other. Okay? Eliminate. Remember, linear combination is the same as elimination. All right. So when I do that, let's rewrite over here. So we've got our original equation, 4x plus 7y equals 28. And then here, when I do this, I get -4x minus 7y equals -28. All right, you might already notice something going on here. So let's start adding things up. When I add the left side, I get a 4x plus -4x. Hey, that's 0. 7y plus -7y is also 0. So we're left with 0 on this side. And 28 plus -28 is also 0. So all of our variables canceled, but now we're left with two things that do equal each other, which means that this is infinite solutions. These are the exact same equation, just one of them has been like multiplied by 2. So they look kind of different, but if we were to graph them, they'd be the same thing. All right, pause here if you want to take a look at that. One more to go. All right, our last one. Remember, we're still using elimination, technically. Linear combination, elimination. So we're looking to see, is there anything that will cancel? I can see I've got a -3y and a +3y. I don't need to do anything to these. They already will cancel when I add up. So I can just straight up add my variables together. So over here, 12 plus -24 will give me -12. -3 plus 3 will give me 0. And -3x plus 9x, or -9x will give me -12x. So when I divide by -12, I end up finding that x is equal to 1. So that's part of our answer. Now to solve for the second part, I need to take this x and plug it back in. All right? Or you can try to cancel out your x's to solve for y, whatever works best for you. So let's take our first equation, -3x minus 3y equals 12. And I'm just going to take this and replace my x with it. So -3 times 1 minus 3y equals 12. And we just solve it out like a normal equation. I'm going to add my 3 to both sides and divide to find that y is -5. All right, please let me know if you have questions on any of this, and I will see you all on Tuesday. Hopefully you're ready for your quiz.